can, sure. And I will.
Okay, we're going to look at the section 8.4, hypothesis testing, z-test for a proportion, 8.4. What is it? The test value for proportion? Remember from the last two sections, one of the steps of hypothesis testing was finding test value. So for proportion, like we learn in chapter 7, we have to use z-test. So the test value start with the name of the test, z equal to p hat minus p divided by a square root of p times q over n, where p hat is sample proportion x over n, p hypothesize a population proportion, and by the way, q is the complement of p. X is the number of sample units that have characteristic of our interest, and n is our sample size. This formula, the test value is in for your formula sheet. So you have test value for proportion, and so far we look at test values for mean. There were two of them, depending if you were using z-test or t-test. And before I go to this example, the steps are the same as before. The first step, you're going to give me null hypothesis, HO, then alternative hypothesis, then tell me which one is the claim. By the way, the claim can be null, HO, sometimes it is H1. So don't think that claim is always H1 or claim is always HO. Then you have to look at alternative hypothesis H1 to determine the tail test, like a left tail, right tail, two tail. Then for the traditional method, the second step, finding the test value, finding the critical value for traditional method, finding critical value. Then third step is finding test value. And then step 4 is making the decision to reject or not reject null hypothesis, HO. We always reject or not reject null, only null. And finally, we have to summarize our result, which I gave you 4 options. You have to pick one of the 4. So let's look at example. A recent study found at most 32% of the people who have been in a plane crash have died. In a sample of 100 people who have been in a plane crash, 38 died. Use alpha equal to 0.05, test the claim. Use traditional method. Now, since your alpha sentence is a very short sentence, so your claim, it is given to you in the first sentence. It says that at most 32% of the people who have been in plane crash have died. So that's your claim sentence. And what is your parameter? Since we are dealing with the percentage related to people, parameter is proportion. And your P is 32%. And what is the claim? First of all, I put the problem up there. Let me move this bar a little bit if I can't. Okay, so parameter is proportion P. What is our claim? At most 32% that the people who have been in a plane crash have died. So P is going to be less than or equal 0.32. P is less than or equal to 0.32 at most. Maximum is 0.32, so P is less than or equal to 0.32. And then your sample size N is 100. Then out of those 100 people that we sampled, 38 died. So 38 is your x. N100 x is 38, and your alpha 0.05. Now we are ready. By the way, every time your parameter is proportion, you have to use z-test for hypothesis testing or finding confidence interval. Okay. Before we we go over our steps, let's find p hat. P hat is x over n, 38 over 100.38. P is 0.32. P 0.32, because P is less than and equal 0.32. So P is 0.32. Q, its complement is 1 minus 0.32, which is 0.68. We need all this information in our 5 steps. So first step, the claim goes with null hypothesis because it has the equal sign. So I put P less than or equal to 0.32. You can write the equivalent, P equal to 0.32. You don't have to. And in front of it, I write claim. And what is alternative hypothesis? P greater than 0.32. And since we have P greater than 0.32, we have right tail test. Any question?
One of the things that students have been confused about and asking is about the P's. So P hat always means the sample proportion, okay? And P without the little thing on the top is the population proportion. You have to make distinctions. We have that not just for P's, but also for the standard deviation as well. So,
yes.
And the means. So be sure that you're distinguishing those appropriately, especially here, because somebody else asked me about P for probability also. And so context is what will help you as well.
Yeah, usually the P population proportion is in the claim sentence. Claim sentence gives you the P. Okay, claim sentence gives you the P.
Because you're testing claims about the population. So that's going to be your population proportion. And that's where that's coming from. But that's part of the confusion that's been coming up.
Second step is finding your critical value. Your critical value depends on your tail test, in this case, right tail test, and on a statistical test, z-test. So second step, finding critical value depends on 2 information, your z-test and a right tail test. And if you look at the handout that you already have, critical value for z-test, right tail test is inverse norm of 1 minus alpha. So inverse norm of 1 minus 0.05, and that gives you 1.65. Or if you're using your calculator, 1.64, but if you memorize it, 1.65, it doesn't matter, 4 or 5, I accept both versions. Now we're going to find test value. Your test value depends on what is your parameter and what is a statistical test. Z-test, your parameter proportion. So the formula starts with the name of the test, z-test. So we get z equal to p hat minus p over the square root of p over n. This is in the formula sheet. I put the numerator inside the parentheses. P hat from the previous slide was 0.38. P, which is you find them in the null hypothesis sentence, 0.32. So 0.38 minus 0.32 divided by a square root of whatever number for this formula you have, the last number that you have in the numerator goes under the radical. So you start with that number like 0.32, your P, Under the radical sign, you start with the p. 0.32 times its complement 0.68 divided by, sorry, what happened? Divided by 100. I enter the whole thing. In my calculator, I end up with 1.2862. Don't forget parentheses around the numerator. Okay, that's your test value. Now, step 4 is to decide to reject or not reject null. Okay? We always decide to reject or not reject null. For traditional method, you draw your Z-curve and put your critical value, locate your critical value on your graph. And since we are dealing with the right tail test, you shade the right tail. Here is our Z-curve. Here is the location of your critical value, 1.65. Shade the right tail. The tail here is the critical region. It's complement non-critical region. Then I had a test value, 1.2862. It is smaller than 1.65 critical value, so it's going to be on its left side. And I will see that my test value is falling in the non-critical region. So I'm not going to reject null. So do not reject null, because test value Z falls in the non-critical region. Last step, we have to summarize our result. Summarizing the result depending on two things again. What was our claim? In this example, the claim was HO, null hypothesis, and in step 4, we did not reject null. So claim HO, and we did not reject HO. So I gave you a table of outcomes. Here it is, table of outcomes. I gave this table in section 8.2. Claim is HO, here it is. If you claim is HO and you did not reject null. So one of the boxes is do not reject null. So you take this information and just copy it. So there is not enough evidence to reject the claim. You have to always underline is not, reject, or support, or is. Okay, you have to underline these, because by underlining, I can see the information better, figure out what you have written, then I can return your quiz or exam as quickly as possible. Any question?
I just wanted to point out again that another name for the critical region is the rejection region. So if you're doing the traditional approach and you fall in, your test statistic falls in the critical region, it falls in the rejection region. So you're going to reject the null hypothesis. Another problem that some people have been having is how to decide how to reject the null based on both of the methods, the p-value and the traditional approach. And that's the difference.
Okay, thank you. Second example, from past records, a hospital found 37% of all full-term babies born in the hospital weigh more than 7 pounds and 2 ounces. This year, a sample of 100 babies showed 23 weigh over 7 pounds 2 ounces. At alpha equal to 0.01, test the claim. Use traditional method. Okay, so I look at alpha sentence. I have an alpha in my sentence, and it's a short sentence. So I have to do hypothesis testing. Since the short sentence is, my claim has to be at the beginning of the problem. Here is, it says 37% of full-term babies born in the hospital weigh more than 7 pounds 2 ounces. So we are talking about percentage related to a group that we are interested in. So our parameter is proportion. And in this case, the claim is that P equal to 0.37, okay? The 7 pound and 2 ounces is just some information about the weight of the babies. So don't mix this up and say claim is, let's say, P larger than 7 pound 2 ounces. No, 7 pound and 2 ounces is just related to the weight of the kids. But here we are parameter is proportion, so P is equal to 0.37. The sample size is 100, X is 23, and alpha is 0.01. We are using traditional method. Okay, parameter, proportion, P. Parameter is population measure, so proportion, P. Claim P equal to 0.37. N is 100, X is 23, alpha is 0.01. Again, since we are dealing with proportion, we always use z-test. I'm going to find my p hat because I need it in the test value formula. P hat is x over n, 23 over 100, 0.23. P was given to me at the beginning and is my claim, 0.37. Q, which is complement of P, is 1 minus 0.37, 0.63. Now, the first step, claim goes with null hypothesis because it has equal sign. And what is my alternative hypothesis? P not equal to 0.37. We always go with the opposite of R, either HO or H1. So H1 is P not equal to 0.37. I look at my alternative hypothesis and it gives me the name of the tail test, two-tail test. Now, since I'm dealing with traditional method, the next step is to find critical values. Critical value depends on the z-test and the two-tail test. So look at your handout and we get a critical value is plus or minus inverse norm of 1 minus alpha over 2. So plus or minus inverse norm of 1 minus 0.01 divided by 2. When you're entering this information in your calculator, do not enter plus or minus, just enter inverse norm of 1 minus 0.01 divided by 2. Whatever number you end up with, ignore its sign, then copy the number, then attach plus or minus. Okay. So your critical value is positive and negative 2.58. Since we have a two-tail test, we need two critical values. Now I need my test value. Test value formula, you can copy it from the formula sheet. Again, to find my test value from the formula sheet, I have to know what is my parameter, in this case, P, proportion, and my test, z-test, a statistical test. So formula, z equal to p hat minus p divided by square root of p times q over n. P hat was 0.23, here it goes, minus 0.37p. You can find the p from the HO sentence, divided by a square root of 0.37 times 0.63 divided by divided by 100. Don't forget to put your numerator inside parentheses. Denominator, the fraction has to go under the radical sign. So I end up with negative 2.8997 as my test value. You see that the procedure is the same as the last two sections, 8.2 and 8.3. Now I have to decide to reject or not reject the null hypothesis, HO. So I draw my Z curve. And remember, you had a two-tail test. You locate your critical value on your Z curve. That separates the critical region from non-critical region. Then after you do that, then you locate your test value on the graph. Here it is, my Z-curve. Here is my positive critical value, 2.58 on the right side of 0 line, and shade the right tail. Then this is my other critical value, negative 2.58, shade the left side of that. Again, the left tail is critical region, and the region in between is non-critical region. And my test value is negative 2.8997, is a little bit smaller than my critical value. Here it is. So locate that. I see that my test value is falling in the gray region, which is critical region. So I'm going to reject my null hypothesis, HO. Any question? Okay. Last step, we're going to summarize our result. It depends on two things. What is our claim and what did we accomplish in step 4? So our claim is null hypothesis. And in step 4, we rejected the null hypothesis. Claim is null hypothesis. Step 4, we rejected null HO. So we look at the 4 outcomes that I gave you. Here it is. You see that on the PowerPoint, I always give you these. So you don't have to give it to me during your exam or quiz, but for teaching purposes, I give you this so you understand where everything is coming from. So claim is HO, here it is, and I rejected HO here. Then I just copy this summary. There is enough evidence to reject the claim. Don't forget to underline is and reject. Again, if you do not underline your is, your reject is not, or the word support, I deduct points, and I mentioned that in class, and you have to put your step numbers in a box. And every hypothesis testing problem has 4 steps. 5 steps, sorry, 5 steps. So step numbers have to go inside a box when you're doing your homework or quizzes. That's the end of example number 2. Any question? Okay, let's look at it. I'm going to, this example, we're going to use p-value method. A survey by Men's Health magazine stated that 14% of men said they use exercise to reduce stress. Use alpha equal to 0.10. A random sample of 100 men was selected and 10% said they use exercise to relieve stress. Use p-value method to test the claim. Could the result be generalized to all adult Americans? Okay. Again, since we are dealing with the percentage of people that we are interested in, our parameter is proportion. What is our claim? P, population proportion, is equal to 0.14 from the first sentence.
Make
What
sure you
is
understand why it's 14% and not the other percentage.
Okay, let me explain that, Shana. The 10%, since is in the sentence regarding sample, that would be your p-hat. Anything that is in the sentence regarding sample size is going to be sample measure. In this case, population sample proportion is p-hat. So we're going to use z-test. So p-hat is 0.10 because it's in the same sentence as sample size. P from claim sentence or from HO sentence, 0.14. Q 1 minus 0.14, 0.86. So in this example, I gave you N, but I didn't give you X in the sample sentence. Instead of giving you X, I gave you a percentage, which is your P hat. Okay, so where do I put my claim? The null hypothesis. So HO colon, don't forget to put your parameter, P equal to 0.14 claim. Alternative, P not equal to 0.14. And we are looking at the two-tailed test. Question.
You do have a question in the chat.
Okay, what is it, Shauna? I am not,
P-
I cannot see chat.
P hat is like X bar, right? Only that is for the proportion.
Wait,
Sorry.
P hat is sample proportion, P hat. P hat is sample proportion. X bar is sample mean.
So they're both sample statistics.
Yeah, they
but
are
they're
sample
not,
measure. Yes,
but
they are
they're
sample
not
measures.
for the same parameters, but
Yes,
they are both sample statistics.
yes. If your parameter was mean mu, then sample measure would be X bar. Okay. But here, since proportion is your parameter, sample measure is P hat here. Again, I also, beside giving you a handout on critical value, p-value, and confidence coefficient, I gave you a handout with a table that I separated your sample measure, population measures, and the parameters that we are working. That is very, very crucial. So you can also attach that handout to your other handout regarding CV, PV, or confidence coefficient, or in the attach it to your formula sheet. That handout is crucial. Okay, now since we are using p-value method, the second step is to find your test value. All the steps for traditional method and p-value method, again, is given to you in the formula sheet. So test value, your parameter is P, and we are using statistical Z. So here is, again, one more time, the formula. P hat was 0.10. Here it is. P is from null, 0.14. So 0.10 minus 0.14, put them inside parentheses, divided by a square root of, I ended the numerator with 0.14. I start the denominator under the radical sign with 0.14 times 0.86 divided by 100. I end up with the test value of negative 1.1528. Now we have to find our p-value. P-value depends on two things: our statistical test, z-test, and our two-tailed test. A p-value is the area of the tail. Here we have a two-tailed test. So to find the area, we use normal CDF. So first of all, I need my test value. Z is negative 1.1528 and is negative. So I find the area of the left tail and I double it and I get my p-value. So p-value is 2 times normal CDF of my left bound negative infinity and my right bound Z. Normal CDF of negative infinity as Z gives you the area of the left tail because my Z is negative. If Z was positive, I would find the area of the right tail and then double it. Remove this bar. So you get 2 times normal CDF of negative infinity, comma, negative 1.1528. from step 2. Okay, I'm repeating this again. This is the last line from the previous step. Use your calculator. You get the area of the left tail is 0.1245. Then I'm going to double it. I get 0.2490. Question on p-value.
Note that p-values are always positive. Z-values can be positive or negative, but
Not z-value, critical value.
your p-values should be positive.
P-value is area, so area is always positive. Critical values can be positive and negative, depending. If you have a left tail test, you have critical value negative. Right tail test, critical value positive. Two tail test, critical value positive and negative. These are with the z-test and t-test only. In the next section, we look at critical value of chi-square. Okay, now step 4, we decide to reject or not reject null. To do that, for the p-value method, we compare our p-value with our alpha. I always write my p-value on the left side, alpha on the right side. P-value was 0.2490, alpha was 0.10. And I read my sentence from left to right. So 0.2490 is larger than 0.10. So it means that my p-value is in the non-critical region. My sample measure is close to my population measure. So I will not reject null. So every time your p-value is larger than alpha, it means that our sample measure is close to hypothesized measure. So we do not reject null. If p-value is less than or equal to alpha, then we reject null. And finally, our summary. Our claim was a null hypothesis, and we rejected null. Null hypothesis, and we rejected null. So there is not enough evidence to reject the claim. I mean, sometimes examples that I choose, like in this section, all the claims were null. But don't think that the claim is always null. Sometimes the claim is H1, alternative hypothesis. Like Shauna was telling me that in one of the sections, the homework that I assigned, all the claims were H1. They can be, I mean, but don't think that the claim is always H1. No, it can be H0, like this section. Sometimes it's H1, like one of the homework sets that I gave. I don't know, okay? So it changes. You have to read the claim sentence and figure out where the claim goes.
And remember that for those of you that have been asking to identify what the claim is, that's a critical reading skill, and that's where your common phrases are going to come in. That's what those 2 slides of common phrases are for. If you want more detail on distinguishing the claims and finding the claims and the null hypothesis versus the alternative, watch the video on that. There's a separate video just on distinguishing those. Watch that. I go through the common phrases and I tell you which one represents the null, which one is the alternative. And I go through several examples. Some of them are not from the homework, and that's by design, so you can see how other things are written.
Thank you, Shauna. Any question?
Any other questions?
Okay, I'm going to start this next section. 8.5.
8.5, okay.
Again, we are looking at hypothesis testing, this time regarding variance and standard deviation. We are going to use chi-square distribution. So chi-square test for variance or standard deviation. Again, these steps are exactly the same for traditional method and the p-value method. So I'm not going to repeat it, but the only thing that changes from section to section and is the test that we use. And depending on what test we use, the test value formula changes, and also finding critical value and p-value. So what is the test value for chi-square test? Since our test is chi-square, the formula starts with chi-square. So chi-square is equal to n minus 1 times s to the power of 2 over sigma square, where n minus 1 is degree of freedom, n is the sample size, s to the power of 2 is sample variance, and sigma square is hypothesized population variance. You will find it in echo sentence. So n minus 1 times s to the power of 2 divided by sigma square. Now, how do we find our critical value for chi-square test using our AD4 calculator? We need significance level alpha in this chapter and next chapter and chapter 12. We always give you level of significance alpha. For a right-tailed chi-square test, we use alpha with degree of freedom. Then critical value is inverse chi-square of alpha and degree of freedom. Inverse chi-square is a program that I gave you in class. For the online section, the program is given to you in the PowerPoint, and I also gave you a link how to write that program. If you didn't want to write the program, I also gave you a site that you can find that is inverse chi-squares or inverse T or inverse norm. These are for both class, online and hybrid. Okay, for a left tail chi-square test, you need 1 minus alpha and degree of freedom. So critical value is inverse chi-square of 1 minus alpha and degree of freedom. By the way, since chi-square distribution is a positively skewed distribution, no matter what type of tail test you have, like for instance, if you have a left tail test, your critical value would be positive because you have a positively skewed distribution. Your curve starts from 0 and goes to the positive infinity. The same thing with the right tail test. For a two tail test, as I said, critical value is positive because we are looking at a positively skewed distribution. For a two tail test, you need alpha over 2, 1 minus alpha over 2, and degree of freedom. One of the critical value is inverse chi-square of alpha over 2 and degree of freedom. And the other critical value is inverse chi-square of 1 minus alpha over 2 and degree of freedom. Both of them are positive. One more time, because a chi-square distribution is a positively skewed distribution. Again, critical value calculator, which is online. Here is the link. You will see this in all sections of this chapter. 8.2, I think, 8.3, 8.4, and 8.5. So inverse function calculator, inverse norm, Z, inverse T, inverse chi-square. And even that site has F distribution, which we will get to this F distribution in other chapters. Okay. Let's look at example. 18 5-gallon containers of fruit punch are selected, and each is tested to determine its weight in ounces. The variance of the sample is 6.5 square ounces. Test the claim that the population variance is greater than 6.2 square ounces. At alpha equal to 0.01, at alpha equal to 0.01. Test the claim that the population variance is greater than 6.2 square ounces at alpha equal to 0.01. Use traditional method. Okay. First of all, I go to my claim sentence and figure out what is my parameter. My parameter is variance. Parameter is population measure. My parameter is variance, sigma square. Okay, parameter is variance sigma square. It is given to you in the claim sentence. And what is my claim? Sigma square is greater than 6.2. Sigma square greater than 6.2. What is my sample size? 18, N 18. 5 gallon is description of the fruit punch, the size of the fruit punch. N is 18. The variance of sample, S to the power of 2 is 6.5 square ounces. Your alpha is 0.01. And since we are dealing with parameter variance, we are using chi-square test. Same test that we use in chapter 7 for confidence interval. Okay, step 1, where do I put my claim? Well, I see that my inequality that I have in the claim sentence doesn't have any equal sign. So my claim goes with alternative hypothesis, H1. Here it is, H1 colon, I just copied the claim. I said, this is a claim. And I write my null hypothesis, sigma square, then I write the opposite of my sign, which is here, opposite of greater than is less than or equal. So alternative, null hypothesis, sigma square less than or equal to 6.2, equivalent sigma square is equal to 6.2. And I also need the tail test. So I look at the name of the test is in the direction of alternative hypothesis. Sigma square larger than 6.2. So I'm looking at the right tail test. Okay. Now, since I'm using traditional method, at the second step, look at your formula sheet. You have to find critical value. Critical value depends on 2 things. One is your tail test and statistical test. Statistical test, chi-square test, and your tail test, right tail. So look at the handout that I gave you. So critical value is inverse chi-square of alpha and degree of freedom. Critical value is inverse chi-square of 0.01. That's your alpha. And degree of freedom, n was 18. Degree of freedom is n minus 1, 17. Enter it in the formula, the program that I gave you, 33.4087. Let me stop sharing this PowerPoint and show you my calculator, share my calculator, and remind you about the program. Shauna, can you have the information of alpha and degree of freedom for me? Shauna?
Yes, I hear you.
Okay, thank you.
Can you hear me, Professor?
Yes,
Okay.
yes. So here is my calculator. I go to the program button. Here it is the program button. I have 3 programs. I need for this section, I need inverse chi-square. So on the top row, when you click program, always stay on execute. Do not move to the right. Okay, just stay on the execute. So the name of the program is highlighted inverse chi-square. I press enter. Then it says program inverse chi-square. The blinker is coming. It's asking me, this is the program you want. To get rid of the blinker, I just press enter. I'm saying yes. Then it asked me what is area right. What was that?
0.01 alpha.
0.01, your alpha. Your degree of freedom?
17.
17, n minus 1, 18 minus 1, 17. Then you click. Here is your critical value, 33.4087. Any question from anybody?
Not so far that I'm seeing. If you have a question, let us know.
Okay, here, 33.4087. Okay, and now third step to find our test value. Test value depends on my parameter in this section, in this example, sigma square, and my statistical test chi-square. The statistical test parameter variance. So I go to the formula sheet and I copy the formula. So chi-square equal to n minus 1 times s to the power of 2 divided by sigma square. In this example, I gave you sample variance, s to the power of 2. I already gave you s to the power of 2. So n minus 117 times 6.5, you are not going to square it because I already gave you s to the power of 2. And sigma square from null sentence is 6.2. If the parameter was a standard deviation, then you had to square your numbers. But with the variance, if you are dealing with the variance, you will not square the numbers. So you get 17.8226. That's your test value. Next step is to make the decision to reject or not reject null. With the traditional method, we have to draw our statistical test, in this case, chi-square curve. We have to draw our curve, which is chi-square distribution curve, which is positively skewed curve. And then I have to separate critical region from non-critical region, and I use a critical value. Here it is. 33.4087. The right tail, because we were dealing with the right tail test. So right tail would be critical region, and complement of that non-critical region. And you see that your chi-square curve starts from the origin. So any value for this test is going to be positive. Then I will locate my test value on the graph. Test value is 17.822, which is smaller than my critical value, 33.4087. Here it is. My test value is falling in the non-critical region, so I do not reject null. Question?
Not seeing anything here so far.
Okay. So the last step, we have to summarize our result, step 5. So our claim was alternative hypothesis H1, and we did not reject HO. So I'm going to look at the summary that I gave you, the outcomes. Here is the summary or outcomes. Claim was H1, here it is. I go to H1 line, and I did not reject it null, here it is. So my summary is there is not enough evidence to support the claim. Now here you see that the claim is H1. In the previous section, majority of my claims were HO. Question. And in a step 4, you always, no matter what the claim is, always you are rejecting or not rejecting null hypothesis, no matter what the claim is. Okay, what happens if I ask you to do the problem using p-value method? So how you have to find p-value. These are the procedure of finding p-value. Remember, p-value is the area of the tail. So you have to find area of the tail. You need the test value, chi-square. Remember, in this section, test value chi-square is n-1 times s to the power of 2 divided by sigma square. Then, if you have a left tail test, and your chi-square, again, is going to be always positive, your test value. You have to find the area of the left tail. The p-value is chi-square CDF, area to the left of chi-square, your test value, and degree of freedom. Now you want to find the area of the left tail. Remember, your curve starts from the 0. So you don't have negative infinity here. So you get chi-square CDF of 0, chi-square CDF of 0, your test value, and degree of freedom. Remember, area of the left tail, we do not have negative infinity because our curve is a positively skewed curve. It starts from 0. So our left bound is 0 for an area of the left tail. For a right tail chi-square test, again, chi-square, your test value is positive. This time you need the area of the right tail. You have positive infinity, but you don't have negative infinity. So p-value is chi-square CDF, area to the right of test value and degree of freedom. So p-value is chi-square CDF. All the functions that have CDF attached to them gives you the area. Okay, gives you the area under the curve. Chi-square CDF of test value, positive infinity, and degree of freedom. This formula gives you the area of the right tail of the chi-square curve. Okay, what happens if you have a two-tail test? Remember, your test values are always positive. So I cannot compare my test value with the 0. Okay, so what do you compare your test value? Because for a two-tail test, when you are finding your p-value, you have to find either area of a right tail, then double it, or find area of the left tail and double it. Now, since our test value is always positive, I cannot compare it with 0. So what do I compare it with? I'm going to compare my test value with degree of freedom. With degree of freedom. For t-test and z-test, I compared my test value, z or t, with 0. Here I compare it with degree of freedom. If test value is less than degree of freedom, then I'm going to find the area of the left tail, area of the left tail, 0, chi-square degree of freedom, area of the left tail, and I double it. That gives me p-value. Now, if test value is larger than degree of freedom, I find the area of a right tail, chi-square CDF of chi-square positive infinity and degree of freedom, Whatever I end up with, I double it, multiply it by 2. The result is my p-value. This information given to you in the handout. Question of how to find p-value for chi-square test? Okay, you will see the procedure in example. A cigarette manufacturer wishes to test the claim that the standard deviation of the nicotine content of its cigarettes is 0.802 milligram. Assume the variable is normally distributed. A sample of 20 cigarettes had a standard deviation of 1.2 milligram. At alpha equal to 0.05, test the claim using p-value method. Okay, my alpha sentence is very short sentence. It says at alpha equal to 0.05, test the claim, and also in the same sentence, it's telling me use p-value method. So it's not giving me any information about the claim. So the claim is going to be in the beginning of the problem. In this example, first sentence. I look at the claim sentence and I say, what is my parameter? Sorry, my parameter, standard deviation, sigma. Now, what is my claim? Sigma is equal 0.802 milligram. The sigma is equal to 0.802. What is 20? My sample size. What is 1.2? Since it's in the same sentence and the sample size, it's going to be sample measure. Which measure? Standard deviation, S. S is 1.2, N is 20, alpha 0.05. Parameter, standard deviation. In the claim sentence, claim sigma is equal to 0.802. N was 20. 1.2 was S. Alpha is 0.05. And since the parameter is a standard deviation, we're going to use chi-square test. Now my 5 stars stop. 5 steps stop. My claim goes with null hypothesis, HO, because it has equal sign. So that's my claim. What is my alternative hypothesis? H1, sigma not equal to 0.802. And this is a two-tailed test. With the p-value method, you have to find your test value. Test value is in the formula sheet. You need your parameter, standard deviation, and your tail test, statistical test, z-test. Chi-square test. So what is the formula? Chi-square equal to n minus 1 times s to the power of 2 over sigma square. I told you in the previous example, if we are dealing with a standard deviation, we usually give you s and sigma. So n was 20. So 20 minus 119 times, I gave you s, 1.2. Now here I have to square it because I gave you a standard deviation, not variance. I square. Divided by sigma square. Sigma is in the claim sentence. I square 0.802 also. So I enter this fraction in my calculator and I end up with 42.5370. Any question?
Not seeing anything in the chat.
Okay, thank you. Now, step 3, with the p-value method, the steps are given to you in the formula sheet. We have to find our p-value. I need to know what type of statistical I have, chi-square and tail test, two tail test from step 1. So for a two-tail test, I have to find either the area of the right tail or the left tail. To decide that, I compare my test value, in this case, chi-square, and I found it in the previous step, 42.5370, with my degree of freedom. My n was 20, so degree of freedom is 19, correct? So test value 42.5370 is less than 19 degree of freedom. So test value is less than degree of freedom. So I have to find the area of the left tail, then double it. So p-value is 2 times chi-square CDF of 0, which is my left side of my curve, then my test value and degree of freedom. This chi-square CDF gives me the area of the left tail. Now, if chi-square was large, actually in this example, chi-square is larger than degree of freedom. Yeah, sorry. Yeah, chi-square is 42.5370, degree of freedom 19 is larger.
So
we
we're
have to
doing
find the
the
area of the
right,
right tail.
the right tail, right? Okay.
Chi-square larger than 19, so we choose option double star. So p-value is 2 times chi-square CDF of right tail. So you start, your left bound is your test value, right bound positive infinity, degree of freedom 19. So you end up with a 0.0015. That's the area of the right tail. Then I multiply it by 2, I end up with 0.0030. So my test value, 42.5370, was larger than degree of freedom, 19. So this is the two options that we have for a two-tail test. In this case, we use the second option. So p-value 0.0030. Any question before I go to a step 4? Okay. Now I have to decide to reject or not reject null. To do that, I compare my p-value with my alpha. P-value is 0.0030, alpha is 0.05. I see that 0.0030 is smaller than alpha. So I'm going to reject null because my p-value is falling in the alpha region, rejection region. And why am I rejecting null? Because my sample measure, S, is far away from my population measure, sigma. And that's not a good news. So we're going to reject null. Okay. And lastly, we have to summarize our result. Step 5. Okay. I need to know what is my claim. In this case, null hypothesis. And I rejected null in step 4. So I look at the 4 outcomes. Here it is. Which one should I pick? Claim is HO, and I rejected HO. I use the upper left box. Summary. There is enough evidence to reject the claim. Question. So you see that the procedures are exactly the same. And no matter with the traditional method or p-value method, we have 5 steps. With the traditional method, we have to find critical value, whereas with the p-value method, we have to find the p-value. No critical value for p-value method. P-value for p-value method, critical value for traditional method. Okay, any question before I go to the next slide?
Not seeing anything here so far.
Okay. Okay. If you remember in section 8.1, I mentioned that there are 3 different methods to do hypothesis testing. Traditional method, p-value method, which we have been going through these 2 methods throughout this chapter. There is one more method, it's called confidence interval method. I'm only going to give you the steps, but we are not going to go over this method in this course. If you are going to take another statistic class in another school, then you will see this method later on. Okay, the first step of confidence interval method is the same as before, the other 2 methods. You state your hypothesis, then you indicate what type of tail test you have, then you identify your claim. Then the second step, you have to find confidence interval. Confidence interval. You do not find p-value, critical value. You find confidence interval. You do not find test value either. So 2 of the steps, finding either p-value or critical value, and also finding test value, those 2 steps are gone from traditional p-value. They are changed to 1 step. They're combined to 1 step, finding confidence interval. Then you have to make a decision to reject or not reject null. How do you do that? If your confidence interval contains the value of your parameter stated in null sentence, you do not reject null. So you find your confidence interval. If the statement in null sentence, if the parameter, the value of the parameter from null sentence is inside your interval, if it's between the left bound of your interval and the right bound of interval, you do not reject null. If the confidence interval does not contain the value of the parameter stated in HO, then you're going to reject null. So if the value that you have from HO sentence, if it is outside your interval, okay, you reject null. Then you summarize your result. So 2 of the steps, finding critical value or test value from traditional method is combined, is reduced to 1 step. The same thing with the p-value method. Finding p-value and test value is reduced to just finding confidence interval. We are not going to look at any example, nothing. That's it. I just gave you the steps. We are done with this section. The extras are using tables. You don't need, in this class, you don't need tables, but if you have to take another stat class and you have to find these values using table, you can look at the tables, the extras that I have given you. Any question? Okay, we are done with section